Okay, let's look at the homework 5.2, 5.3, number 9. Right? So we want to sketch the graph of f of x, which is natural log of x plus 6 minus 4. Right? So let's look at that. Right? Domain is you have natural log cannot take a negative number or 0, so it has to be only a positive number. So we have we have to make sure that x plus 6 is greater than or equal to 0. Right? So which means that we subtract 6, so x has to be greater than or equal to negative 6. Right? So if you want to write it interval notation, so it's going to be inclusive negative, or actually, sorry, we cannot do 0, so it has to be greater than 0 and greater than, so it's going to be interval notation is so negative 6 and then positive infinity. Right, so let's type it in. Right, domain is negative 6 and positive infinity and parentheses. Right, so check that. Right, got that. Alright, then we want to find the x-intercepts, so we're going to do that. Alright, x-intercept, so we're going to set y equals 0. So you have a natural log of x plus 6 minus 4. We're going to set that equal to 0. Right, so we just have to solve this. So add 4 to both sides, so you have a natural log of x plus 6 is equal to 4. Right, so a natural log is hard to deal with, so natural log takes x plus 6 to 4, so the exponential function takes 4 back to x plus 6. Right, and we can just subtract 6 from both sides, so that way you have e to the 4th minus 6 is equal to x. Right, so let's type that in. Right, so you're going to have e to the 4th minus 6. Right, check that. Right, got that. Alright, next one is y-intercept. So we're going to set x equals 0. So we can just say f of 0, which is equal to natural log of 6 minus 4. Alright, so let's type it in. Alright, this is going to be a natural log, so ln of 6 minus 4. Alright, so let's check that. Alright, got that. Alright, then we want to find, let's say, increasing, decreasing. So we're going to do a first derivative. So let's look at that. Alright, take the first derivative of this function. Alright, derivative of a natural log of x plus 6 is, so we put x plus 6 on the bottom. Take the derivative is, we'll put it on top, it's 1. And derivative of negative 4 is 0. Right? So we have that. And let's say there's no, so this guy is never 0. Right? So we cannot get it that way. And negative 6 would make this undefined, but the negative 6 is not in the domain. So you have no critical numbers. Right, no critical numbers. Right. All right, but this quantity, when x is greater than negative 6, right? So it's greater than negative 6. So this guy is always actually positive. So f prime is always positive, right? So which means that increasing on its domain. So we have, go back. So function is increasing on the subinterval, so it's going to be from -6 to -6 to infinity, positive infinity. Right? So check that. Right? Got that. Right? Function is decreasing on a subinterval, so it's never decreasing. So check that. Right? We got that. Right, then function has a local max at, okay, local max and local min. So you can see that here, since function is always increasing, so there's no local max, right? So there's no local max, right? Got that. And a local min, and it's always increasing, so we know that there's no local max. So there's no local min. Right, got that. All right, so we're gonna talk about concavity. So let's look at the second derivative. All right, so this is the first derivative. So we take another derivative. All right, so we can use the quotient rule to take the derivative. All right, so square the bottom, x plus 6 squared. All right, derivative of the top is 0 times bottom, which is going to be 0 anyway, minus top 1 times derivative of the bottom, which is going to be 1 again, right? So this guy, 0 times anything is 0, so that goes away. So what you get is -1 over quantity x plus 6 squared, right? Which means that this is going to be always negative, because the negative sign, this is always positive, so this is always negative. So which means that it's always concave down. All right, let's see. So go back. All right, so it's a concave upward, so it's never concave up. All right, so got that. All right, concave downward. Okay, so it's always concave downward, so it's going to be from -6 to positive infinity. All right, so we have that. All right, the function has an inflection point. Since it's always concave down, so there's no inflection point. All right, got that. And continue. All right, then here. So it has to be always increasing and concave down. So it looks like this is not going to be it, A is not going to be it, D is not going to be it, it's going to be these two guys, right? Then the domain is -6, so let's open this up. This guy starts from the, looks like the positive, so B is promising, right? So it's starting from -6, so it looks like it's -6, so this should be it, right? So let's choose B and a check, right? Right, that's it. I hope that this was clear.